Today we are going to learn about optimizing SQL queries, tips for faster performance. We'll dive into techniques to boost query speed and efficiency, enhancing your skills in database management.
Welcome to our video on optimizing SQL queries. Efficient query writing is crucial for minimizing database load and improving response times. Today, we're exploring practical strategies to enhance the speed and efficiency of your SQL queries. From understanding execution plans to leveraging indexes, we'll cover everything you need to know to get your databases running smoothly. Whether you're dealing with large datasets or just want to improve your skill set, this video is packed with insights to help you optimize your SQL performance. In this section, we'll delve into query execution plans, a vital component in SQL optimization. An execution plan is a roadmap that your database engine follows to execute your query. Understanding these plans allows you to pinpoint inefficiencies and optimize performance. Execution plans are generated by the database system to determine the most efficient way to execute a query. By examining these plans, you can identify the most time-consuming parts of your query and make informed decisions to optimize it. Tools like SQL Server Management Studio or MySQL Workbench offer visualizations of execution plans, making it easier to understand complex query paths. By regularly analyzing execution plans, you can ensure your queries are as efficient as possible.
Indexes are one of the most powerful tools at your disposal for speeding up SQL queries. An index is a data structure that allows you to retrieve data from a database table more quickly. Think of it like an index in a book, helping you find information faster without scanning every page. There are primarily two types of indexes, clustered and non-clustered. Clustered indexes sort and store the data rows in the table based on the index key, while non-clustered indexes maintain a separate structure from the data rows. Properly indexing your tables can drastically reduce query time, especially for large datasets. However, it's important to avoid over-indexing, as this can lead to increased storage needs and slower writes. Understanding when and how to use indexes is key to optimizing your SQL queries.
The explain command is a powerful tool for analyzing the performance of your SQL queries. By running explain before a query, you can see how the database plans to execute it, revealing the cost of operations and potential bottlenecks. This insight allows you to make informed decisions on how to optimize your queries. The output of explain includes critical information such as the order of operations, index usage, and the estimated number of rows to be processed. By understanding these details, you can adjust your query structure, index usage, and even table design for better performance. Familiarize yourself with common explain terms like rows, filtered, and type to get the most out of this tool. With practice, you'll be able to leverage explain to fine-tune your SQL queries effectively. Subqueries and nested queries can be tempting to use for their simplicity, but they often come at the cost of performance. Subqueries are queries nested inside another query, which can lead to unnecessary complexity and longer execution times. Instead, consider using joins, which can often achieve the same results more efficiently. Joins combine rows from two or more tables based on a related column, cutting down on the need for multiple passes over the data. By converting subqueries into joins, you can streamline your queries and reduce execution time. For example, if you're pulling data from multiple tables, using an inner join can often be more efficient than a correlated subquery. Understanding the trade-offs between subqueries and joins will help you write faster, more efficient SQL queries.
Join operations are fundamental to SQL, allowing you to retrieve data from multiple tables in a single query. Understanding the differences between inner and outer joins is crucial for optimizing your queries. Inner joins return only the rows that have matching values in both tables, while outer joins return all rows from one table and the matched rows from the other. This distinction can have a significant impact on performance, particularly with large datasets. When optimizing joins, it's essential to ensure appropriate indexing on the columns being joined, as this can drastically reduce query time. Additionally, consider the size and structure of your datasets when choosing between inner and outer joins, as one may be more efficient depending on your data. By strategically leveraging joins, you can create powerful, efficient queries that meet your data retrieval needs. The where clause is a critical component in SQL queries for filtering data. By narrowing down the dataset, you can significantly improve query performance. The key to optimizing select statements with where clauses lies in understanding the relationship between the clause and your indexes. When a where clause can leverage an index, it dramatically reduces the number of rows that need to be scanned, speeding up the query. Additionally, combining multiple conditions in a where clause with logical operators like and more can refine your data set even further. However, be mindful of the order and structure of these conditions, as they can impact performance. As you craft your where clauses, consider the underlying data distribution and indexing strategy to ensure optimal performance.
Using select in your SQL queries might seem convenient, but it can lead to significant inefficiencies. This practice retrieves all columns from a table, often pulling more data than needed and increasing the load on your database. Instead, specify only the columns you need for your query. This not only reduces the amount of data processed but also improves the clarity and maintainability of your SQL statements. When working with large datasets, the impact of retrieving unnecessary columns can be substantial, resulting in slower query performance and increased resource consumption. By being intentional with your column selection, you can write more efficient and effective SQL queries that are easier to understand and maintain. Let's explore some real-world examples of query optimization in large datasets. Consider a complex query used in an e-commerce platform, where performance is critical for customer satisfaction. By analyzing the execution plan, developers identified that a lack of indexing was causing slow response times. By introducing appropriate indexes and restructuring some queries, they achieved a 70% reduction in query execution time. Another example comes from a financial institution processing millions of transactions daily. By minimizing the use of nested subqueries and optimizing join operations, they significantly reduced database load and improved overall system performance. These examples highlight the importance of continuous optimization and monitoring, especially as datasets grow. By applying these strategies, you can ensure your SQL queries remain efficient and scalable, supporting your organization's data needs well into the future.
In conclusion, optimizing SQL queries is a critical skill for anyone working with databases. By understanding execution plans, leveraging indexes, using explain, and avoiding common pitfalls, you can significantly enhance the performance of your queries. Remember, optimization is an ongoing process. Regularly analyze your queries, monitor performance, and apply the strategies we've discussed to keep your databases running smoothly. The benefits of optimized SQL queries extend beyond speed, improving resource efficiency, scalability, and overall system reliability. Continue exploring and learning, and you'll be well equipped to tackle even the most complex database challenges.